Good day, class. This video is a review on the double angle identities that you've seen before. So I'd like you all to write down the learning objective, actually it's kind of like a review objective for this lesson. So this lesson, first of all, is entitled Review on Double Angle Identities. Double angle identities. Okay, write that down. The learning objective for this review lesson is as follows. Learning objective. Learning objective is by completing 4 review problems. By completing 4 review problems, you're going to do this on a separate sheet of paper. You will apply the double angle identity. What's that? The double angle identities in evaluating trig functions. Okay, so that's the learning objective for today. So you're going to need to have your formula sheets to make easy reference to the formulas, if that's assuming that you have not yet memorized all the formulas. So let's go ahead and try out an example, and then you can get started with the classwork after this example. Example 1. Write this down. If secant theta equals -4/3, and theta is between 90 degrees, 90 degrees is less than theta, and theta is less than 180 degrees, find sine 2 theta, cosine 2 theta, and tan 2 theta. Okay, we're going to find all three of this, of twice this angle, evaluate whatever the angle is. Alright, so let's go ahead and start on this problem. So let's see. First thing we want to do is identify the double angle we want to find first. How about we look for sine 2 theta first? So everybody write this down, sine 2 theta. What is sine 2 theta? What on earth is that in using the formula sheet in the expanded form? What is sine 2 theta equal? So if you look at your double angles identities, the sixth box, you will notice that sine 2 theta is 2 sine theta cosine theta. This is the only option for sine, as opposed to cosine, which has 3 options. This is the only option. So this is what we need. We need sine and cosine. Okay? So what do we have though? We have secant. So we know that secant theta is -4/3. So let's see. Which can we find first? Sine or cosine? We know that there's a direct relationship between secant and cosine, right? So let's go over a path here that we can create to go from one to the other. We can go from secant directly to cosine. How can we go directly from secant to cosine? What is the relationship? Is it the reciprocal or Pythagorean? If you look at your formula sheet, you know that you see that it's a reciprocal relationship to go from secant to cosine. So that will help us find cosine, right? But we need cosine and sine, right? So let's find cosine first, and then we'll talk about the issue of determining what sine is. So let's find cosine theta. So how do we find cosine theta? We're going to use the reciprocal identity as highlighted here. Cosine theta equals 1 over secant theta. So whatever secant is, you can just reciprocate it, and that will give you what cosine is. So cosine theta is simply negative 3 over 4. You can do it the long way by writing 1 over this, and then you DCF the problem and you get negative 3 over 4. So that's the value of cosine theta. Now we have cosine, we have this component determined, but we also need this part right here. So what on earth is sine theta? Can we find sine from cosine is the question. Is there a way to go from cosine that we already know to sine? Is there a direct connection or indirect connection? It turns out that we have a direct connection. If you look at your Pythagorean identities, you can go from cosine directly to sine. Okay? So we found cosine. Now let's find, I'm going to partition my workspace, and we're going to find sine right here. So let's find sine. So write this down, find sine theta. Okay, because we need sine theta for this piece of the sine 2 theta formula. So to do that, we're going to write down the formula that relates sine and cosine, which is the Pythagorean relationship. If you look at your formula sheet, you will see that sine squared theta plus cosine squared theta equals 1. This is a longer formula. You can use the other one if you're inclined to do so. So let's use this one though. So we're going to have sine squared theta, plug in what I need, and then also plug in what I know, which is that cosine theta is negative 3 over 4. So negative 3 over 4 quantity squared. Okay, equals 1. Now let's solve this. So this is going to become sine squared theta. If you square that, it's going to be plus 9 over 16 equals 1. Now we need to get sine theta by itself. We're going to use 2 steps. We're going to subtract negative 9 over 16 and then square root both sides, and that will give me sine theta. So let's do it. So we'll subtract 9 over 16 from both sides. This cancels out, these 2 cancel out. And then you have sine squared theta equals 1 over 1 minus 9 over 16. We can write 1 over 1 as 16 over 16 is the same thing, the equivalent. So if we minus the numerators, we'll end up with 7 over 16. 7 over 16 is the value of sine squared theta. So sine squared theta is 7 over 16. Let's write that down. Sine squared theta equals 7 over 16. Then what is sine theta going to be? You just do the opposite of the square, right? You root both sides, root the top and the bottom. So since you're taking the square root of a square, sine theta is going to be plus or minus rad 7 over 4. So that's sine theta. So we now have sine theta and cosine theta. The 2 ingredients we need to compute what sine 2 theta is. We have cosine theta and sine theta. Okay? So we're ready to go. So let's find sine 2 theta first. Sine 2 theta is, let's rewrite the formula. 2 sine theta cosine theta. Plug in what we just found. 2 sine is, wait a minute, plus or minus root 7 over 4. Is it plus or is it minus? We need to determine what that is before we can plug it in, so we don't have an ambiguity in our answer. So Let's go back to the angle. What angle are we restricted to, or what quadrant are we restricted to? We're restricted to the measures between 90 and 180. So 90 and 180 takes us to quadrant number 2. We know animal students take calculus. S means sine is positive, so that tells me that sine in this case is going to be positive. So sine theta is √7 over 4. Okay, because sine is positive and we're in the second quadrant. Now, moving along. So sine 2, we're going to plug it into this formula. Sine theta is √7 over 4, as we derived from our work just now over here. All this work, and then cosine theta is -3 over 4 as a consequence of reciprocating what we got earlier from secant. So let's express this as a fraction so 3 of them match. So we just multiply across. We're going to have 2 times 3 is -6. Do the numbers and then write the radical on its own. You can combine them since you're on like terms. Unlike numbers, and then 4 and 4 gives you 16. But you have a common factor here. You can divide 2 into both of them. 2 goes here 3, and 2 goes here 8 times. So your answer for sine 2 theta is -3 √7 over 8. So sine 2 theta is -3 √7 over 8. So we have one answer down. Now next one we're going to find is cosine 2 theta. Let's box this. So we're going to get confused. So that's sine 2 theta. Now we need to find cosine 2 theta. Now cosine formula, we have 3 options. We have cosine square theta minus sine square theta, option number 1, or 2 cosine square theta minus 1, option number 2, or 1 minus 2 sine square theta, option number 3. You can pick whichever one you like, but I think this option right here, the one that's dependent on cosine, is the optimal choice here, because if you look at the problem, we're able to get cosine by simply reciprocating secant. So this is a very accurate result. I don't know how accurate this is, so it's less risky to use this as the option. So I'm going to use this one. But if this is the correct answer, the second formula should work, and if they're both accurate, then the first one should work. So I'm going to use this one right here. Okay, I'm going to use the formula that's dependent on cosine. So let's use that one. So we're going to have cosine 2 theta on color. Cosine 2 theta equals 2 cosine square theta minus 1. And that's going to give me 2 times, what is cosine? Cosine is -3 over 4 right here, right? So 2 times -3 over 4 square minus 1. And then when you square that and multiply by 2, you're going to have 2 over 1 times 9 over 16 minus 1. That gives us 18 over 16. This 1, we can write it as 1 over 1, right? So LCD of 16 and 1 is 16, so this one needs to have a 16 in the denominator, so I can combine it. So I can times this by 16 top and bottom. So we end up with 16 over 16. And then when you subtract, you get 2 over 16. And then you can reduce this to 1 over 8. So there goes cosine 2 theta. So cosine 2 theta is 1 over 8. Alright, now let's move on to the last one, which is tan 2 theta. Now we have 2 options for tan 2 theta. For tan 2 theta, we can either use the identity 2 tan theta divided by 1 minus tan squared theta, or we can use sine 2 theta divided by tan 2 theta. Divided by cosine 2 theta. I prefer this option because we already know sine and cosine. So we just find the quotient of these two results, this one, and that will give us our result. So let's use that idea, okay? So we're going to use this option, tan 2 theta, this option right here, equals sine 2 theta over cosine 2 theta. So let's look at our first result. For the numerator, we have negative root 7 over 8. For the numerator, negative 3 root 7 over 8 divided by cosine 2 theta is 1 over 8. So we're going to divide these two. So you're dividing by fractions, same thing as multiplying by its reciprocal. Or you just DCF it, okay? You drop the top, negative 3 root 7 over 8. Change it from division to multiplication, and you reciprocate the denominator, 8 over 1. Okay? The 8's cancel out, and your final answer is negative 3 root 7. And that's the value of tan 2 theta. Alright, so there goes our third result. Okay? Now you're going to get started on some practice classwork problems. Thanks for watching this video. Have a good day.